So welcome everybody to example 5 of using the ratio and root test. So once again, in this case, we're asked to use the root test to determine whether the series will converge absolutely, whether it will diverge, or if the test might be inconclusive. So let's take a look at what the root test actually says. So for the root test, we look at the limit as n goes off to infinity of the nth root of the absolute value of our nth term. That will be some value rho. Now, if rho is in between 0 and 1, the series will converge absolutely. If rho is greater than 1 or infinity, then we know that the series will diverge. And in the case that rho is equal to 1, our series test will be inconclusive, and we would have to try something else to determine whether the series actually converges or diverges. So let's look at that limit, our limit, as n goes off to infinity of the nth root of the absolute value of our nth term, which in this case is 4n raised to the n power, divided by natural log of n raised to the n power. So again, the root test is kind of a natural thing to do because our terms are raised to the n power, so we immediately simplify those things. The nth root kills off our nth power, and we really just have the limit of 4n over the natural log of n. And so for this, if we imagine this being a continuous case or a differentiable case, then we have an infinity on top, we have an infinity on the bottom, and so we would turn it over to L'Hopital's rule. So if we look at the limit, as x goes off to infinity, of 4x over the natural log of x, we do have that infinity over infinity indeterminate form, so if we apply L'Hopital's rule, then this is going to be the same as the limit as x goes off to infinity. The derivative of the numerator becomes 4, the derivative of the denominator becomes 1 over x, and so we have the limit as x goes to infinity of 4x. Well, quite naturally, that gives us a positive infinity in that case. And so we end up with the value in our first case for our series also being infinity, and so we are able to conclude from the root test that the series diverges by the root test. So again, this has been kind of a short and sweet, quick example of showing when the root test will give you a series that diverges. So I hope you've enjoyed it, and I will see you guys next time.